Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Pocek, and this week in the news we have a new ASIC miner. ASIC stands for Application Specific Integrated Circuit. This is a dedicated chip to make the mining more efficient. Specifically, this is about Bitcoin mining. So with this new chip, it is more efficient to find a crypto puzzle for Bitcoin blocks. I will talk about how this works in a upcoming lecture. So this is the link here. Let me open it here. So they announced that they have a new efficient chip, and efficient means it uses less energy and it can do more calculations. So all it does is it checks SHA-265 hash sums. So all it's doing is it takes some input, calculates SHA-265, checks how many bits are set to 1. This is the crypto puzzle for Bitcoin. I will talk about this later. And this should be as efficient as possible. And currently they claim they can do this with 26 joules per tera hash. This is quite interesting because right now this is a very good number. However, the competition is also improving their chips. For example, the Antminer, which is announced here from Bitmain. They're one of the leading manufacturers of these ASIC miners. They announced a new generation which has an efficiency of, let me quickly find that, power efficiency here, joules per tera hash. It's 21.5. It's even lower than what Intel is announcing or announced. This will come out in fall, so the earliest I saw here is in September 2022, and the availability of this Intel ASIC is also third quarter here of 2022. So it will be interesting who can deliver the more power efficient Bitcoin miner. The next article is also a reference to the lecture. In the first lecture, in the slide number 5, this lecture here, I briefly discussed that Moore's law, which says that the number of transistors doubles every 2 years. This will come to an end. And it was predicted a couple of times. This graph shows that the transistor count is around 50 billion. And if we now look at the numbers here, we see that the new processor from Apple, the M1, has double the transistors. But it uses a chiplet version, so it has multiple chips in one processor. If you look at the others, there's the NVIDIA Hopper, which is a GPU, has around 80 billion transistors, and the chip from AMD, 64-core EPIC, has around 40 billion transistors. So here we also see a huge gap. The AMD EPIC we had here on this graph, here is the AMD EPIC, and we see that the next generation transistor count from 50, it doubled. That was roughly 2 years ago, so it's still holding true. Nevertheless, here it says Here it says that single chip processors have reached their limit, and they argue that more and more chiplets are used, so smaller units that are interconnected to each other, so that you can actually have more cores on the processor. So in future we will see more cores, but still the transistor count is increasing. That also means if we have more cores, we need to think about our programming. So if we do programming, we should try to make or calculate as much as possible in parallel what's possible to make use of these cores. Then the next article is about crypto assets, and there's a new regulation from the European Union, and there's a new rule, especially for money laundering. They are planning to make non-custodial wallets traceable. So non-custodial wallets is basically that you have control over the private key. I will talk about private and public keys also in an upcoming lecture, but in the Bitcoin and in most of the chains, if you own the asset, you can prove that by having a transaction signed with your private key, and by holding the private key, these keys are under the custody of the user, so it's not within a bank or within a third party. So this is non-custodial. It's comparable with cash. If I have cash in my wallet, it's non-custodial. I'm responsible for it. Same with Bitcoin and Ethereum. If I have the keys, I'm responsible for it. If this is non-custodial, if I have my wallet now on an exchange like Coinbase, Kraken, Bitstamp, then it's a custodial wallet, and those exchanges, they take care that they have my keys secured. And now this law tries to make this non-custodial addresses that they want to make it attached to a person, so that if there's a transaction from such a provider, Kraken, to a non-custodial wallet, that the Kraken or any kind of other exchange needs to be aware where this cryptocurrency is sent to. And I mentioned that these rules would also cover so-called unhosted wallets. Those are the non-custodial wallets, meaning that they need to identify also the private users which this cryptocurrency is sent to. However, there is an exception luckily. So this is the relevant text, and there's an exception. So if it's a pure peer-to-peer transaction, so if it's from a private person to another private person, then this rule doesn't apply. It only applies if it comes from an exchange, from a custodial exchange to a non-custodial wallet. Then you need to identify both parties. If it's pure non-custodial to non-custodial, then this rule does not apply. And also it would be really difficult to enforce this rule if there would be such a rule. One thing I'm not aware, for example, if you use Monero, Monero is a cryptocurrency for which embraces the privacy aspect. So if you use Monero, everything is anonymized. Nobody knows who sent to which address how much of Moneros, and that is enforced by the protocol, by mathematics. Actually, it uses zero knowledge proofs to actually say or verify, yes, the transaction is correct, but you cannot see how much was transferred or to which address it was transferred. Since with Monero you cannot see if there's an incoming transaction. For example, if you are Kraken and there's an incoming transaction on the Monero chain, you don't know where this address is coming from. So this would be kind of difficult here to enforce this rule. The next item, or the next news item, is also something I already mentioned in lecture 6. It's about Spring for Shell. It's lecture 6 in the news. That was last week, where I mentioned, is it a similar issue like Log4Shell? It was unclear by that time. There was a report that it might be critical. So, but it was not confirmed. It was also not confirmed by the Spring team. So I mentioned that it will be a fun weekend for security teams everywhere. It turned out it was actually a normal weekend, and it's not as severe as Log4Shell. Nevertheless, if you are affected, you should upgrade your system. If you use Spring, typically Spring Boot is not affected. So there is this analysis from the Spring team. They also have a timeline. They looked at it, and they also mentioned that the default distribution, if you use Spring Boot as an executable jar, which most of the projects are these days, then it is not vulnerable, so you're safe. But nevertheless, there is an update available, so I encourage you to update your project if possible. Then in lecture 6, I was also talking about the performance tuning of Nginx. I can quickly go to the slides. Here it's lecture 6, load balancing, and I mentioned in the Nginx section that there is here ideas how to tune, how to make it even faster. And I recently came across a very interesting link which could give you some more ideas, and it uses kernel-based TLS, so that TLS is actually decoded and encoded in the kernel, and the unencrypted is then sent to the user space, which saves some overhead. They also have some numbers. This is already an old article. It's from 2011, so 2021, so last year. And they also made some benchmarks down here, and it's roughly 8 to 29% faster. So it might be worth a shot if you're on the limit, if you have a site and your machine is too slow for that. So that might be an option to switch to kernel level TLS for that. The last article is also about performance comparison between ARM and Intel, which is this link here. So they tried on Amazon, they tried both platforms, both chips, x86 and ARM, and compared it. They compared the bandwidth and disk throughput, and they came to the conclusion that the raw throughput, this looks quite similar. And when looking at the graphs, they also mentioned that the SSD throughput is limited. Well, if it's a shared instance, they limit this to a certain bandwidth. And for me, the question is, what did they measure? Did they measure the AWS limiter? Especially if you look at this graph, which shows that Intel is limiting this a bit differently than if they use the Graviton, the ARM-based processor. But nevertheless, it looks like as they measured the AWS limiter, which does actually a pretty good job. So if you look at those benchmarks, always think if it makes sense, if those numbers look reasonable. So my takeaway is that for the performance, actually, it doesn't matter that much if you use Intel or Graviton. However, what seems to be an impact is that it's actually cheaper. So Amazon is pushing their servers because the Graviton is a chip designed by Amazon. So naturally that they, if it's not that used, so they want to push it and make it cheaper. So this is a valid outcome, but here, for example, comparing the vCPUs from one architecture to the other, I mean, this could be much faster, this could be slower, so it's always difficult if you see those measurements, those benchmarks, and always question if you see benchmarks, does it make actually sense for you?